In this video, we'll introduce the idea of how to find an amount of accumulation using the scenario of a Mars rover. The Spirit rover landed on Mars in 2004 and was active until 2010. It was powered by solar cells. As the rover traveled across the Martian surface, it kicked up dust, which accumulated on its solar cells. The amount of dust that it kicked up depended on the composition of the surface it was traveling over. A rockier surface would kick up less dust than a softer surface. Imagine that scientists are planning to send another rover to Mars and want to know how far it might travel before too much dust accumulates on its solar panels. They have mapped out a 100-kilometer path for the rover to follow and have collected satellite data about the composition of the Martian surface at various points along the route using a LiDAR spectrometer. When the rover has accumulated 275 milligrams of sand on its solar cells, it won't be able to produce enough power to continue. If the rover travels along this path, does it risk accumulating too much dust? The first step in figuring out the total amount of dust that will accumulate is to identify the composition of the Martian surface at various points along the route. Here is a table that shows the composition of the Martian surface at 7 points along the rover's proposed route. And here is NASA's estimate of how much dust would accumulate on the solar cells per kilometer traveled for each type of surface composition. So, based on this, how can we figure out how much dust will accumulate across the rover's entire trip? The first thing to do is to break the path down into distance intervals. And we should figure out the length of each distance interval. The first and last distance intervals are 10 kilometers, and the others are each 20 kilometers. Next, let's make some space to compute the amount of dust we accumulate in each distance interval. The next thing we need to do is to recognize that the data we have is a rate. For example, this 6 means that at a point 90 kilometers along its path, the dust is accumulating on the rover at a rate of 6 milligrams per kilometer. Now, this is just at a specific point along the path. But if we assume that each of these rates is constant over the entire distance interval, then that would mean that to find the amount of dust that accumulates for each interval, we would multiply the change in position over that interval by the rate of accumulation. For example, over the interval from 90 to 100 kilometers, the rover travels 10 kilometers. If we're assuming that dust accumulates at a rate of 6 milligrams per kilometer, then the rover would have accumulated 60 milligrams of dust over that interval. And we could do this for each of the intervals. So, for the interval from 0 to 10 kilometers, we would multiply the 10-kilometer change in position by a rate of 1 milligram per kilometer to get 10 milligrams of dust accumulating. And over the interval from 10 to 30 kilometers would have a change in position of 20 kilometers multiplied by a rate of 1.5 milligrams per kilometer to get 30 milligrams of dust accumulating. For the interval from 30 to 50 kilometers would get 40 milligrams, then 50 milligrams, then 70 milligrams. And if we added all of this up, we would get a total of 260 milligrams of dust that have accumulated on the rover. One thing you might have noticed is that we were always using the rate of dust accumulation at the beginning of each distance interval. For example, for the interval from 90 to 100 kilometers, we used a rate of 6 milligrams per kilometer for the entire interval. However, by doing this, we were assuming that the rate of accumulation at the start of the interval was a constant 6 milligrams per kilometer for the entire interval. We can see that the rate of accumulation had dropped to 3.5 milligrams per kilometer by the end of the interval. So we also could have done the entire calculation using the rates at the end of each interval instead of the beginning. This would have given us a slightly different estimate of the total amount of dust that accumulates on the rover. This estimate using the ending values for each interval would be just as accurate as the estimate we made using the starting values. Now, to summarize our general method, to make an estimation of the total amount of dust that has accumulated, we treat each interval as having a constant rate of dust accumulation. In the example, we always used the rate at the beginning of each interval, but we could also have used the rate from the end of each interval. Then, We find the amount of accumulation over the interval by multiplying the constant rate times the change in position, and then, to get the total amount of accumulated dust, we add up the amounts from each interval.